Alright guys, good morning. This is Jonathan Pierre with CAD Lab CNC, and I'm here to revisit the soft jaw video. Before, what we did is created some type of relief cuts for each leg, and we did that, but I just want to show you guys a little bit of a quicker way to do it, and also I want to throw some tool paths on this soft jaw, and I want to teach you how I actually separate it and what I separate it with. Alright, let's jump over to Fusion 360. Okay, see here we have our two back plates like we had before. But if you notice something different, I got rid of the relief cuts on this side, and this side. Okay, so we're going to only depend on this flat to push against this fixed jaw. Okay, let me turn off the body so I can show you. See, way easier, way faster. Just a little something that can lighten up your workload. Just look for little tricks like that. Okay. We'll jump into manufacture. Okay. So we'll turn off our bodies because we're not really worried about the bodies right now. We need to actually mill these pockets out. Alright. I've already had the tool paths already set, but we'll go over them. Okay. I did a 2D adaptive. Okay. We'll go over it. Did a 2D adaptive. This is the geometry I picked for it. Alright. On this side as well. Alright, my heights. I selected this face to be my bottom, so it doesn't go past that unless if I tell it to. Alright. For my optimum load, I went tool diameter. Now you can edit an expression. See this? This is my tool diameter, which is, I believe we're using a 5/32. So tool diameter times 20%. So 20% of that tool's diameter, I'm taking a width of cut. Okay? If you guys ever want to input an expression in there, you can. You go to edit expression, tool diameter times 0.2 would be 20%. If I go with a very small cut, 10%, then that's 10% of my tool's diameter I'm cutting with, which would be, if I press OK, which would be 156 thousandths, and you get it from there. Okay, but I want to make a little bit of a bigger cut than that, so we'll go 20% of my tool diameter we will be using to cut. Little tricks there, huh? Okay, so we got that. We're gonna leave a radial stock to leave on the wall of 2 thousandths, and on the floor we're gonna leave nothing. We're just gonna go straight down to the floor with it. Okay. And then for my adaptive here, which is my datum hole, this is what we're going to set our second operation. Our first one we're going to cut it. Our second operation is going to be set off of the floor and on this radius for our work coordinates. Okay, so here I set my heights. Now you see these, my retract height and my clearance height are set relatively low, which is going to stop my tool from coming all the way up to the sky and then going somewhere else to cut. I want that tool to lift up and barely touch the surface. I don't want to waste any extra time on that tool in the machine rising too high in Z. I'm going to try to keep it as low as possible, but I'm going to also pay attention for other things, you know, multiple heights. You don't want it to come too high up and then you're going over an X somewhere to go do another pocket and you have a pillar sticking up. You want to recognize your model and see all the heights and what's the lowest point that you can go. That's tip number 2. Alright, so for this one, I also edited an expression, same thing, tool diameter times 20%, 0.2. Okay, and I'm also leaving a radial stock to leave, 2 thou on the wall. I always do that. For me, that's how I get the most cleanest surface finishes on a radius. Alright, and for my contour, I come here. Okay. Now, I take the rest of the meat off. No stock to leave on the floor or the face. Finishing pass. Just one nice clean finish pass. Finish feed rate, 20. 20. We're all good on this. Our heights are fine. I have selected contour, so that means I pick the bottom of this circle and it knows that that's my bottom. But I could also come and just get extra OCD with it and just click the bottom. Done. Okay. And then for now, here is the magic. Here's the magic sauce right here. Okay. Now our part fits exactly in this slot. When we go to mill this part out, we're making it the same exact size of our part. There's no way that that's going to comfortably fit in there. So what I start out with is I start out with a minus 2000s stock to leave on all radial engagement. So this right here, this radial part, I go minus 2000s. This radial part, minus 2000s. I'm giving a little bit of room for the actual piece that I needed to hold to fit in there. I've tried it exactly how it is, and it just doesn't fit. So I always go minus 2000s. And you'll see what I mean right here. Radial stock to leave. This is the final touch that I always put on anything or any pocket that I need something to fit in there. Final touch. Minus 2000, minus 2000, okay? Now let's play the sim really quick. I'm going to try to make this video as fast as possible. Even though most of you guys watch all the videos to the end, which I really do appreciate that. Okay, we're making that. Let me go transparent. We're making that nice little slot there. Or pocket, excuse me. And we're coming down here, making a nice little pocket. Boom, boom. Just cleaning it up nice and boom. Now we're coming here. We're cleaning this area up, getting it nice and pretty. Oh, we did that finishing pass. Now see, we're working our way in there into that relief cut. Same thing on this side. We're not just taking one chunk. Okay. Now my graphics card is pretty good on this computer, but you can kind of see where we'll minus that 2000 at. Okay. Fusion does a really good job on showing you a good idea of where your stock's going to be. Now that's perfect. Okay. All right, guys. Now let's take you over to the Tormach 440. All right, guys. We are inside of the Tormach 440. Okay. So here's what I want to show you. Hold on. Alright, so if you watched our first video on how to draw a soft jaw for this part, remember, we separated the two soft jaws exactly a quarter apart from each other. Alright, so guess what? We have a 1/4 inch end mill. We're going to stick 2 on each side of each other. Now these are ground tools, so that means that they're as closest to a quarter that a quarter could possibly be. So let's do that. All right. Oh, need to open up the jaw, open up the vise a little more. I'm gonna take this guy, put him in there like that. Then we'll come over to this side, put him over there like that. Then we'll take the vise and just turn it until it stops. Don't try to clamp down on it. Just turn it until it stops. See, it's not going anymore. All right, now that's good. Okay, and we'll take our probe. All right, we'll jog down. Our coordinates on X in the program are set right here, okay? And just like before. All right, we'll put our tool to 99. We'll come to probe and we'll probe X positive, set work origin. Okay. Just like that. Now we'll go to Y. Okay. We'll find where our part's at right here. Our probe's here, our part's here. We'll go Y negative. the top of the part, that's C. All right, guys, we're finished. All right, look at these chips. See these chips? These are perfect chips. They're not dust. They're not dust. These are what happens when you edit your expression, okay? That's 20% of the tool diameter we're cutting with this small little 3/32 tool. All right, so we'll open up the vise. We'll take these guys out. All right. Pay attention to your chips, guys. If your chips are like dusty, you're spinning too fast, you're doing something wrong. All right, that's tip number 3. Okay, we'll take our part that we actually did all this for. We'll take our part. And just to make sure, we don't want any chips in any of these surfaces. We don't want any chips in any of these surfaces. Pull that out right there. All right, we don't have any chips on our part. We'll put it in there and we'll see if it fit. Oh man, look at that. Look at that. Goes in there like perfect. Goes in there so perfect. You can't really take it out. It's like a perfect pocket for it. All right, guys, this is why I do a -2000s on the radial stock to leave, okay? Exactly why. See, there's a chip right there. That will be your downfall. All right, boom. Nice and flat. All right, let's see if the other one fits. Oh man, I can't believe it's not butter. I don't know, guys. I'm feeling a little chipper this morning. I'm in my creative. I don't know. What do you think? We should maybe mill the backsides out in the same video? All right, screw it. We're going for it. We're gonna mill these two guys out right now. So we're gonna put our probe in there, tool 99. You guys remember that? Okay. We're in G54. I'm gonna go to probe. Now check this out, guys. We were using XYZ the whole entire time. We're gonna switch this one up now. And what do you have? Find a pocket center. Ooh, I think that's the one. Look at that, it's dancing around the hole. It's checking the X. Boom, coming over here. Checking the other side. It's gonna come back to the center. Checking our Y. That's gonna come check the other Y, the other side of the Y, negative and positive. And when it's done, the probe should lead me directly in the center. Oh man, look at that, beautiful. Now we're gonna come back and we're gonna probe our Z. Boom. Look at those 3D cuts, baby, on a Tormach. Look at that. All right, guys, that's pretty much it for this video. If you guys are interested in us anodizing, electro-anodizing, it'd be my pleasure to make an anodizing video. Also, we were thinking about engraving our CAD Lab logo on the front of it and anodizing the whole entire part, sanding it down, and then anodizing it again for the second time for a double color coat. I don't know, if you guys are into that, you let me know down in the comments. We will be doing a free giveaway to 2 people who have watched this entire video and all the other episodes that led up to this video. We're gonna be asking 3 questions. Whoever is the first to get those 3 right gets the part. Okay, if we run our toolpaths really quick, this is what we saw in the finishing part. Now, I mean, it's not a big deal because we could always just take a hand filer and sand that down, but when you're machining, you want to try to do as less as possible to the part because there is a lot of finishing to do to some specific parts, but this particular one here was completely avoidable. So we'll go ahead and play the simulation really fast, right? Boom, boom, boom. Okay, you see this little slither right here? This is actually left on the part. So how are we going to fix that? All right, we'll come here. We'll go to that finishing pass. We'll look at the heights. All right, we'll look at the heights, and we'll drop down to about. We'll go negative 25 thou. We'll see how that looks. Now you see how it's pushing me past the edge instead of just stopping me right there. Look at that. It eliminated that bump that we had there completely. Okay? The bump that we had is completely gone. Always push that tool past wherever you need to go to get the look you need. That might be a tip 4.